everybody. Welcome back to our channel. So we continue our OpenCV series. We've been on that for a while now, done a couple of interesting projects, very interesting projects. If you want to see the projects we've done so far, I will advise you to look at our previous videos. Done a lot of incredible projects, and we are going to do another interesting project today. So today we'll be looking at post detection, and ultimately a working steps counter using OpenCV and Mediapipe. This library Mediapipe, which we are going to use today for that reason. Now, what's post detection? Post detection determines it takes the structure of a particular object. It can be an animal, it can be any object, it can be humans, but mostly humans. Now, how does that work? It tells you, oh, where is the eyes? How is the eyes arranged? How are the arms arranged? Right? How is the person keeping his legs? How is the person is the person folding his hands? So it's basic is more like it gives a skeletal picture of that object or the person in this regard. So what's basically the use of post detection? It helps us a lot, especially when we are looking at anatomical projects. For example, we may want to monitor our performance, especially when it comes to gym. Gym has to do with keeping your body in a particular position, right? And to build yourself, right? So we can use that to design a system that can monitor how well you are doing in exercises. Of course, yoga is another one of that. You can also use it to check sitting postures. For this, but in our project today, we'll be looking at walking steps, not just the walking style, but how many steps one walks. Of course, we've seen several counters that tells us, oh, you walked 300 steps today, oh, you walked 400 steps today. So you can see it's a very, very important tool, especially when you are doing something like a timer, maybe geography, or maybe you are monitoring your health, or just monitoring your weight. There are so many use cases of such an application. So that's what we are going to do today. So it will be into the video will be in two stages. The first part, or two parts to say. The first part will be we're looking at just the post detection first, right? Because that's what any other application, any other algorithm can be built on. Once you understand the post detection, you can structure it to do other tasks. Then the second part of this video, we're looking at adapting the post detection algorithm to get walking steps, walking steps counter. Great. So let's just dive into it. So now the first one is the post detection. What are the steps that we'll take? We are going to, it's just 4 steps, very simple algorithm. First, we're going to load the image, which you know how to do already using our OpenCV. Then, and as video capture. And then we recognize landmarks on the body, because we're looking at humans, different parts of the body. Then how to connect those landmarks. For example, I can recognize the elbow, right? I can recognize the fingers, but I'll need to also know the connection between the fingers and the elbow, and so on and so forth. Then of course you show image. Remember that post detection is more about getting the skeletal picture of whatever object or the person in question. So once you can connect the landmark, you'll be able to see the object. And of course, you know that once you get the skeletal picture, it's not like you've gotten the pose of that person. All right, beautiful. Let's quickly dive into the code. I've gone so fast to getting two videos here, which we'll analyze. I'll play them shortly. These are the videos we use for this task. Let me just play the videos for you to see. The first video, just basically a man walking across a forest trail. on video. This is the second video, which is just a man just walking on the road. So I think I prefer this video for the counter because you can easily count the steps here. So so those are the videos. So let's quickly run into this. So I'll go this off. Let's quickly create our, let's just call it post detector. Right, so that's our Python. So first of all, we'll import the major files, the major libraries. In this case, we'll import CV2, very important, OpenCV. Then we import Mediapipe. Mediapipe is normally used for almost all post dictation tasks, and because it has a lot of features, we won't have to write things from scratch. Then we have and then beautiful. So that being said, those are the important libraries. This is not very important, so let me just take it out for now. Because you know what NumPy does, numerical analysis, and then we also know what Mediapipe does. That's what you do. So let's just take NumPy out. If we need it, we are going to bring it back. All right. So first of all, let's load our video. So we're going to load our video. So so we are going to use video. This you can also use webcam. It's basically the same thing. So just call it video part is equal to. So I'm going to use. Let me just use the first video. Then of course, cap is equal to, we've done this severally, video capture. Okay, so two dots. Right, now you can, this just basically goes to check the video. So if it sees the video and it can open it, it's fine. If it does not, we can simply say give something that will tell you, no, I cannot open the video. So let's just open it. So while cap dot is so all right, this will return false or true. This is each frame, which will be equal to cap dot read. Then as if return gives false, right? So what will happen is we're just going to print not. Alright, so that's just housekeeping. However, if we can, then I think after we've done this, we just break out and then of course end it. Right, break then what will happen is we of course, and then so let's destroy all windows. This is just basically housekeeping what we've been doing before. So however, if that does not, if we can see the frame, which we hope we can, as with most of the cases, we get our frame, right? And then remember that OpenCV gets frame in BGR, so we have to convert it to RGB. You can either use reversing or you simply use a feature of CV2 color, CVT color. Let me just do it. So our RGB frame will be equal to CV2.CVT color CV2.CVT color, then frame, then CV2 dot color BGR to RGB. Alright, so this is now our frame. For each of them, that's our frame. Now the next thing we do is for us to detect pose, carry out pose detection. So we've gotten alright, we will need to carry out our pose detection now on the frame. So for us to carry out pose detection, we have to initialize our pose to say. So we have to initialize our Mediapipe model to be able to carry out pose detection. So let's just initialize it outside here. So I won't be initializing it every time we are going through the frames. Once we've gotten our model, our Mediapipe model, we'll go back to always be initialized. That's what I'm doing it outside. So let's just call this NP pose. So NP pose will be equal to NP, which is Mediapipe.solutions.pose. So this is library for getting the pose, right? This is just for initializing the pose. Remember that we've not loaded this pose model, model first, like we've not structured it to what we want to use it to. Now, one thing is to go and fetch it, another thing is adapt it to what we want to use it for. Adapt it before even using it, adapting it to the way we want to use it. So let's now adapt it to the way we want to use it. So let's load it. Let's load it. So now how do you load it? Okay, let's just call this pose will be equal to np pose, right, which is the initialized Mediapipe, right, dot pose. We want to use the pose, and now this pose can take many attributes, but we're just going to take two attributes. One of them will be a detection confidence, how well it detects the pose and how well it detects that object, human object, and then how good is it at detecting the at doing the model, how good is the model doing its detection. You also have to check out the minimum tracking confidence. Okay, so it's not a must. Some people use the default value, but I just like to initialize mine. So, let's just put that 0.5, and then we also have minimum tracking, which is equal to 0.52. Okay, I think that's fine. I hope I've closed all the, I think there's a comma here. Okay, beautiful. Now that that's been done, we are going to use this our pose that we've initialized for detection. We use it for detection. Now, how do we do it? We simply fit it the way we normally fit our models. Just process, right? Just process. So we are going to fit it and we'll get some results. So result is, what did I call it? Pose, right? Pose dot process. We use it to process our RGB, right? We use it to process our RGB. Then there are things we are interested in. These results can give a lot of things, right? You may want to print this out and read what it gives. There are so many things it can give, but the most important thing is that it will give us our landmarks, the different parts of the body, right? The different parts of the body. So we can say it's called results dot post landmarks, right? Beautiful. So you can print these landmarks if you want, but it's not so important. Just give you the different marks of the different part of the body, so you can do that on your own. Then we also need to draw so that we can see, right? We can see the landmark. So we want to draw on the object itself. After getting our landmarks, different part of the landmarks, right? We need to draw so that people can see it. Is so I'll just call a pencil. That's a tool for using in drawing Mediapipe attributes on OpenCV or other images. So let's say it's mp.solution. Let's just call it drawing utils. So this is a utility for drawing using Mediapipe, right? So now we want to draw on the object itself. So I don't know, let me just see. Let me just print this result so that we can see how it goes. No, I think I'll print the result when I'm running it. Or should I? Yes, I think I should just print it. Let me just print it so you can see it. It's just different parts of the X, Y, and Z of the different parts of the body. That's what it's going to give you. I don't really think it's going to, because I've not done image show here, so it's not going to show any image. It just give you different parts of the body. All right, you can see the landmarks. We have X, Y, Z, different part of the landmarks. X, Y, Z, X, Y, Z, X, Y, Z. It's possible for me to tell you the different landmarks that it has seen. I'm going to do that now. It actually Mediapipe, for the human body, Mediapipe produces about 33 landmarks. So let me just print it out for you to see the different 33 the different landmarks. So we're going to print the landmark, the 33 landmarks. So so that it's going, no, it won't print everything here. I'll just put it here. So print so print l dot name or l in mp post dot post landmarks. Alright, so this is going to print. Let's just run this quickly. Right, so these are the landmarks: the nose, the left eye, the left inner eye, the right index, the left thumb, and so on and so forth. So these are the landmarks that Mediapipe can see in a human body. Okay, so let me just remove this and let's continue with our code. We've done that. What do we need? Well, the only thing left is for us to draw our landmarks, right? Draw our landmarks on the image. So if we only draw if it can find any landmark, that means sometimes there may be no person in that video or in that frame, not that video, so there may be no landmarks to draw. But if there are landmarks, we simply use our pencil, which we had already defined earlier, the draw landmarks, right? So this is another feature of Mediapipe used to draw on images. So what are we going to take? That image we want to draw on, which in this case is our frame, right? Either our frame, yes, our frame. Why am I using the frame? Remember that we are processing on the RGB, but we don't want to draw on the RGB because OpenCV will mistake BGR for RGB, so we are actually drawing on the original frame. Okay, so we draw on, this is a frame. It also takes our landmarks. What are the landmarks? And it also takes another very important feature, the connections. You need to connect these landmarks. This is the nose, this is the eye, but how are they connected together? So this is mp dots. We have pose dots, pose connections, right? So this is it. You can print this out if you want to see how they are connected together, but I don't think that's necessary for this video. So I want to also make it longer. So now this is the only thing we need to draw. So once you've drawn on it, what else but to just show cv2 dot aim show. Let's just call it pose detection, and then the frame, and then okay, we do this every time. Why do we do this? So that we know when we stop, right? When we want to stop. There are two ways you can stop. Either the video finishes, right? Or I just press Q. Once I just press Q, it stops. So let's just do that. We've been doing it in other videos, so it's not new. So this and 0 times ff equals to Q. Of course, it takes in ASCII, so we use other Q. I don't know. I don't need to cram whatever it is. So if that is an arm break, and once I break, of course, it will come here to cap the release. So let's just make this. All right. I think that's everything. I hope you understand. That's the entire code. You get the video. You carry out pose detection, right? Detect the pose, right? The connections. You take the landmarks. Then you get your pencil, right? Which is a drawing util. Then you now draw both the landmarks, which will be drawn as circles, and then the connections will be drawn as lines, right? So the landmark will more be like the joints, and the other ones will be like the bones, right? The line to just connect them, and then we'll show it. It's just a very, very algorithm. So let me just run that for that first video. Hopefully we don't have any error. All right, so you can see this. Beautiful. So that's that. So let's try and run it on a second video. So up to the point where it cannot detect any longer. So let me press Q and then you're done. Let me run it on the second video, which is output 2, and see how that works too. Okay, so this is it. This is for the second video. Beautiful. So that's that. So let's quickly so that's that for the first section. So we'll move to our next section, which is using the media pipe for post, using this for post for steps counter, right? So and we are going to use this video to do that. So these are the steps that we are going to take. We are going to get the input, which we know how to do. We're going to do post detection, initialize post detection, which we know how to do too. Then we will extract landmarks, which we know how to do too. Then after that, we'll do something different. We are going to calculate angle. Now, how are we going to do this? How are we going to get our steps? I discovered that when you raise your heel, right, your ankle, right, between the heel and the toe, the toe tip and the heel, right, there's this ankle between them, right, between your leg ankle itself is just between your foot index and your heel. So when you raise it, you cannot walk if you don't raise it. So when you raise it and then you drop it, you've made one step. You raise it and drop it and then you've made one step. So I know that the position of the toe tip, the position of the angle and the foot index changes. So what I will do is that if I know the distance between the two of them, I can calculate the angle. This angle, I can calculate this angle. Just basically this is how it is. So I know this AH, I know this AH, I know this AF, right? And I don't need to know this because this is your foot itself. I know this and I know this. With these two, I can calculate this angle here, right? I can calculate this angle here using the cosine rule. So I can just take the arc cos of this for me to get this angle. So that is what we are going to do. We're going to do the angle calculation. Then once that angle is greater than a particular threshold value, which we are going to put at 30 degrees, I know that my leg has risen, right? Once it goes below, I know that my leg has come down. So if after my leg is down, it now raises again above that 30 degrees threshold, I know my leg has gone up again, and I'll count that you have done another step. Because why will you raise your leg if you are not doing a step? So that is just the logic that we are going to use. So whenever the foot is raised, I count a step, right? But I will keep a dummy because you can keep raising your foot, right? I only say 30 degrees, can go higher than that. So I don't care once you reach 30 degrees. I don't care if it keeps going higher. But once I come down, I bring my foot down. I know that if I'm raising the foot again is another step. And of course, I understand that we have a right and a left foot. So I'll simply use one of them. We'll simply use one of them. Any of them can work. So let's quickly go to our code and then do that. The code that you wrote earlier, we'll simply adapt this code for our second part. So what are we really interested in? We are interested in the ankle. We are interested in the foot, the right heel, and we are also interested in the right foot index. That is the toe. Okay, beautiful. So first of all, how do I get this? Let me just take this down. So I have to get the landmarks. This itself is the entire landmark. So I have to get into this and get the landmark. So let me, what do I call it? Have I called anything landmark? Okay, let me just call it landmark. Right, let me just call it landmark, which will be equal to landmarks dot landmark. Again, so these are the different landmarks, and we knew the we saw the different part of the body. So we are interested in the right ankle, we are interested in the right heel, and we're also interested in the right foot index. So we are going to get those out. So the next thing is for us to extract necessary landmarks. So for our own, we'll be using the right leg. Of course, it could also work for the left leg. I just use the right leg because personally, I take my left leg first, left leg first, and then my right leg follows. So when I've completed making my a step is actually when my right leg follows my left leg. I may just be stretching my leg if I push my leg. That's for me. But you can always change it to the left leg. It depends on if you are right footed or if you are left footed. All right, so let's simply extract it. So we have okay. So that's that for this. We've gotten the right angle. Of course, we went and got this post landmark dot right angle dot value the x, and then um from here we also got the y value of the right angle, the x and y value of the left angle, and the x and y the x and sorry this should be this x and y of this. So this is left. Beautiful. So that's been done. Beautiful. So the next thing we'll do is for us to calculate the angle. Remember, we are saying if the angle is more than 30, we are lifting up our leg. So angle is calculate. Let's just create a function to calculate the angle to make the code more modular. Calculate angle. No, this is wrong. We are looking at the right here, and this should be the right here. The right here, and then calculate the angle between right ankle, the right heel and the right foot index, because I want the right ankle to be in the middle. You may ask, does it matter? Yes, it matters. If we are looking at an angle between ABC, it matters which is in the middle. Okay, beautiful. So that being said, the next thing I want to do is for me to write a function that will do the calculate angle. Before I write that function, it has given me the angle. Let me just complete this. If angle is greater than 30, right, and not foot raised. Now, what do I mean by foot raised? Remember I said that you can keep going and going and going and going and going. I just keep raising my foot. But once I bring it down, I know that anytime I raise it again, I'm taking another step. So I need to know that the foot is not being raised, right? It's not, I know frame after frame, the foot will be going, then to come down, right? So I'll just initialize outside here that there should be a function that says foot, a constant that says foot raise is equal to false originally. So if it's not foot raised, then I will count my count plus equals to 1, right? Or steps plus equals to 1, and then I will now say that my foot raised equals to true. Alright, so I think I've used something new here. Steps. It seems to understand steps. Did I use it before? Let me check. No, I did not use it before. So I'm wondering why I understand what steps is. So let me just initialize it to 0. Yeah. Okay. Foot is, so elif angle is less or equals to 30. What I'll do is, in this case, is foot raised is equal to false. Right, so that's that. I think that's everything. Then at the end of the day, when I'm showing, I think I also add a text. Right, when it's done, I'll add a text to show that cv2.putText. it will always be showing on the frame, right? It will always be showing the steps. So this will be steps. Call it steps, right? So it's going to tell you the steps, and let's look at the size. Where will it be? Not the size. So 50, 100 at top, and then the font. I think I'll just use a font HA Simplex, but we've been using it, so it's not as if it's something that we'll not be using. Font Simplex, font HA Simplex. Alright, then font size 2. Then the color will be Simplex 2. Okay, 2. Then the color will be 0. Let's make it green. 2550. And then next one. Okay, I think with that we've added the text there. Then of course the next one will be show. The next one will be show, to show it for us to see. Let's see now, to make sure the show is within the while loop. Okay, it's within the while loop. So now the next thing we'll do is for us to create the function for calculating the angle, right? The function for calculating the angle. So def calculate ABC. So our A will be np.array. Okay. Our B is equal to np.array B. Our C will be np.array C. Right, you have to change all of them to array so that we'll be able to carry out numerical operations on them. Beautiful. So that's being said, of course, you know that we need NumPy to do all this, our cosine and cosine and so on and so forth. So BA is equal to remember we're looking at BA and BC. What is in the middle is B. BA is A minus B, and then BC, just the formula we had shown earlier. BC is equal to C minus B. Alright, beautiful. So our angle np dot So our angle is remember we have to convert a computer angle in radians and then we now convert it to degrees. So np dot degrees, np dot arc cos. Remember the other one was our cosine angle. Um, np dot cosine angle minus 1.0 1.0. All right, so I don't think there will really be time to the use of this numerical component. You can simply look at the NumPy array, look at the NumPy and how this is carried out, right? Because it's this will be a video on its own. However, if you want me to make this video for you or to explain it clearly later clearly in the comment, just let me know. I'm going to explain this actually simple maths. This is a simple way of expressing that equation I showed them earlier. All right, beautiful. So now I'm going to return the angle. All right, so that being done, I think you're going to see the angle here, and I think that should be the entire code. So let me just run this and see what we have. All right, normalize landmark list. Please, sorry, we changed this. We changed this to landmark, not landmark. So this should be landmark. It should be landmark. So come in. Yeah, landmark. It should be landmark. It should be landmark. 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 So let's run that again. You can see. Okay, seems to be working very well. All right, so let's look at the second video. Okay. All right, so it seems to be working well too. Okay, so all right, so let's run our code. Let's run it now. Yeah, so it seems to be working well. 7. All right, it seems to be working well. Let's just change the video and use the other one. All right, this seems to also be working well too. Great. So that's everything for the video today. Please, if you, it's a very simple algorithm. So if there's anything you don't understand, just add it in the chat. If you need to add anything, as I always say, we learn every day. Just add it in the chat. If there's something you want me to expand more, especially this part of the code, you can also add it in the chat. I don't want to make the video longer than it is. I will have explained that. But in any case, thank you very much for watching our video. I'm always grateful. So, but please don't fail to like and also share, and also come back for more videos. Thank you. Of course, computer vision is our love, so we will always be here. Thank you.